Welcome to a lesson with Dr. Powell. Let's get started. We're going to look at how we can write x to the n more simply in polynomial modular arithmetic when we mod out by a linear factor raised to a power. Here, let's just square it. So we're looking for a simpler representative of this. Now we can expect when we divide by x minus 3 squared that anything we get will, for a remainder, will be at most degree 1. So we can expect this to be something of the form ax plus b. Now, it does not quite work to use a system of equations with plugging in different things like we did in another video, but rather, here we're going to use the technique of Taylor series, a Taylor series centered at x equals 3. So let's write this. F of x is equal to x to the n. That's our function. And as a Taylor series, we can think of this as centered at x equals 3. We can think of this as being f of 3 plus f prime of 3 over 1 factorial times x minus 3 plus f double prime of 3 all over 2 factorial x minus 3 quantity squared, and it keeps going. But notice when we mod out by x minus 3 squared, any multiple of x minus 3 squared is equivalent to 0. So all this goes away and everything thereafter goes away, since even x minus 3 cubed has x minus 3 squared as a factor. So that goes away as well. All we're left with when we mod is this. So we're pretty much almost done. We just plug in 3 into here and notice that we get 3 to the n. Next, we plug 3 into the derivative of f, but we can compute that. The derivative is n x to the n minus 1. Plug in 3, and so then we'd have 3. Well, then we would have n times 3 to the n minus 1 all over 1 factorial, which is just 1, times x minus 3. So we would end up we'd end up getting this, and you can simplify this perhaps, but pretty much this right here is the representative that we desired. Thanks for watching.